And these tunnels actually we attach to Geo Power Plants, which means to power plants that are located beneath the surface, and they get the high temperature and the energy from the geothermic heat that we extract and can harvest with the tunnels.
Good. How do you prevent the tunnels from collapse?
Well, actually this is a very good question, because it was for quite a time the concern, and it is still today with all the mining and all the tunneling systems, that very often they do not realize and recognize the balance in the subterranean area. And if you balance this with pressurized tunnels, then you stabilize the area, which means with the walls that we create, thermoelastic walls of our tunnels, inside we pressurize these tunnels, we create really a stronghold even in regard of earthquakes. If you have locations prone to earthquakes, then you really are in danger if you do not have a very stable tunnel. And this is what we do and what we achieved and accomplished in our research.
How long do you think it would take from if you had initial funding to do your work, to actually production of some sort of power?
Yeah, I think actually with our present calculation, if we get this started this year, within 5 years we can produce geothermic electricity, which means with each tunnel we can produce about 2 gigawatt, which means it serves for 500,000 people, or homes. I have to say better, homes.
Okay. Connected to this research, you've talked to me a little bit before about this tower.
Yeah.
Would you like to tell me a little bit more about that?
Well, actually the idea with the tower came up when we said, look, the footprint of our Geo Power Plants is actually zero. The only thing that comes out of the hole is, or from the power plant, this is located underneath the surface, is actually the electricity. Now, to teach people, to educate people about this, what we are doing with the vertical tunnels and all the associated energy-related projects, we thought it is wise to have a building there where we can educate the people, where people can live in, and this on a scale that is right now only in a few big cities. Let's say in Chicago, the Sears Towers. These are the guidelines that we looked and where we learned people can live there, 20,000-30,000 people in such a tower. We can have museums, we can have cinemas, and we have ball dancing room and everything you can imagine, from Walmart, shopping going, you can have really sports and conventions and everything in one location. And this is, I think, exciting, especially if you look how we bring more homes and settle the country, you know, and destroy the country with single homes and houses. Of course, we will not stop this, but the increasing population demands that we also look into these new opportunities with big towers, where we can educate people, where we can feed people, and of course use as incubators for other innovations too.
Okay, so would the towers actually be almost off the grid themselves? Each structure would be self-sufficient?
Exactly. Each and every of these structures is self-sufficient, and all the tenants or the owners of floors or whatsoever, you know, they can get for 1 cent per kilowatt hour, you know, such a low price that it becomes very attractive to businesses and entrepreneurs.